This is the Chapter 9 test review with Mr. V. I'm going to be doing the odds. If you'll notice on the top of your review, you'll have all those formulas. So make sure you keep those in handy as we go throughout these. So the first one I'm doing on the odds, if I didn't say that already. The first one here, we're looking at what is the area of each figure below, round to the nearest tenth. So you can tell this side is equal to this side is equal to this side. So what I would need to do is, where is the 90 degrees coming from? So if this top is 10, this bottom's 10. And we know that this 90 degrees is coming from right here. So I know that the base of it's 10 and the height of it would be 4. And since this is just the area of a parallelogram, it would just be 10 times 4, which is equal to 40 meters squared. All right, so this third one here looks to be a rhombus because everything's equal. So these are all equal, and then these are equal to these, which is good. So what we would need to do here is on our rhombus, it's just diagonal 1 times diagonal 2 over 2. So if I erase this just so you guys can see the diagonals, this diagonal right here is going to be 7 because it's 3.5 each. So I'd have 7 times, and then this is 4 here, and this is 4 here, so it'd be 8 over 2, so that's 56 over 2, and I would just go to my calculator. 56 divided by 2 is 28. So it'll be 28 centimeters squared. All right. Keep moving along. Unless Mr. Cladis wanted this whole thing to be 4, because then I would do 7 times 4 over 2, so that would be 28 over 2, and then that would be equal to 14 centimeters squared. So it really depends on what he means by, is this whole thing 4 centimeters, or is each one of these segments, this segment here and then this segment here, each 4 centimeters. So we'll have to ask him about that one. All right, number 5. So if this is 4.5 and this is 7.5, then this is 3, then this is 3. All we gotta do is add them up for each diagonal. So 3 and 3 is gonna be 6 times 7.5 plus 4.5 is gonna be 12. So 6 times 12 is 72. 72 divided by 2 is going to be 36 meters squared. So there's your final answers. So it could be, again, either one of those two, depending on what we find out the diagonal to be. All right, find the area of the shaded region. All angles are right angles. So what I'm going to want to do is I'm going to want to find out the area of the entire thing first. And then, like I said before, imagine this is a window. There's nothing here. So that's empty space. So that doesn't count as area of the shaded region. So I'm going to just find the area of the whole thing first, which is just 18 times 12. So 18 times 12 is 216. So this whole thing is 216 centimeters squared. But I need to find what this area right here is. I can just do 4 times 3, and that's 12. So I'm going to minus that. So 216 minus 12 is going to be 204 centimeters squared. Find the circumference of the circle in terms of pi. So what that means is you just leave the pi symbol. You don't have to multiply the pi. So we know the circumference of a circle is 2 times pi times r, okay? And over here, I just leave my 2, I leave my pi, And then I got to find the radius. If this whole thing is 8 and that's the diameter, then if we just cut it in half, that would mean the radius is going to be 4. Okay? Now I can then multiply these. So 2 times 4 is 8. So it would just be 8 pi. And again, I'm leaving the pi. So your final answer is 8 pi centimeters. And that's circumference, which essentially means it's the perimeter of the circle. So we don't square that. 11, find the area of each circle using approximation of pi, if necessary, around to the nearest tenth. So, if our radius is 9 inches, so look, we can just draw this here. And this circle right here, this is 9 inches. So what we need to know is that the area of a circle is going to be pi times r squared. So I'm going to do that. I'm going to do pi times the radius, which is 9 squared. Order of operations tells us that we got to do the 9 squared first. So that would be like saying pi times 81. So then 81 times pi is going to equal, let me see if I did this right. I did do it right, all right. It's going to be 254.5 inches squared. All right, for this one, if this whole thing is 8, that means the radius, which is just half of it, is going to be 4. So I'm going to have, it's just pi r squared, right? So pi times 4 squared. 4 squared is 16, right? So I'm just going to do pi times 16. And I do 16 times pi on my calculator, and I get 50.3. So those are your two final answers right there. All right, find the area of each polygon. It looks like that what we need to do is we need to cut this in half, but can we cut it in half? So let's figure out what we need to do to get this done. So 15 looks a lot trickier than it actually is. So just remember that we're always looking for this right angle, and that's where your base is. So if you were to say, imagine rotating it one turn this way, so kind of like fell. So then it would look kind of like that. And then I hope you can catch my drift. It's hard to explain, but imagine if this whole thing went to the left, and then we had our 90-degree right here, and that said 7, and then this base right here was 15.1. We know that for finding the area of a parallelogram, what we would need to do is just 15.1 times height, which is 7. So 15.1 times 7, it's going to be 105.7 feet squared. So again, I didn't need to chop this up or anything like that. I just needed to realize that the 90 degrees is right here, and it looks weird. I understand that. Like the bottom looks like a triangle, the top looks like a triangle, except for it's got that one edge on the bottom left. But if you were to rotate it, or even rotate your paper to the left one turn, you'd be able to see that it does have a base. So our base is going to be this line right here, and then the height is going to be the other part of the 90 right there. So our two numbers are 7 and 15.1. Find the area of each polygon. So the first one looks to be a triangle. Our triangle, when we're finding the area of a triangle, what we need to do is the same. It's almost the same as like a rectangle parallelogram. However, we just need to divide it by 2. So our entire base here is 3 and 4, so that'd be 7. So this is 7, and our height is 3. So I would do 7 times 3, and then I'm going to divide it by 2. So 7 times 3 is going to be, let me see which number I'm on here. Yep, 7 times 3 is 21, and then 21 divided by 2 is going to be 10.5 inches squared. Something very similar here. So the base is going to be 12, and our height is going to be 10. So even though the 90 degrees right here, we know that the dotted line means that's just an extension. But the height is 10, and the base is 12. So 10 times 12 over 2. So it'll be 120 over 2, which is then equal to 60 centimeters squared. That's your final answer. All right, that was 19, so this is 21. Let me plot these points real quick. All right, so after I plot these points, I see that it is a rectangle, and this side's going to be 3. This side's also 3. And then the base is 1, 2, 3, 4, 5, 6, 7, 10. And it just wants me to do the area, so I can do the base times the height. So that'd be 10 times 3. So then 10 times 3 is going to be 30. We don't know what the units are, so we're just going to do units squared, and that's it. All right, 23. Let me plot this real quick. All right, and then for 23, after I plotted it, this is what I found. I realized that if I just make this my 90 degrees, because that is 90 degrees right there, this would be the base would be 1, 2, 3, 4, 5. And then the height of this would just be the length of that, which is 1, 2, 3. So then I would just do 5 times 3, and then I would get 15 units squared. Now, one thing that we could also do, if you really wanted, we know that this is going to be 5. So this side is 5 no matter what, right? And let's see here. So there's really no other way to find the height. So there's no other way to do it but just to draw that 90 in there right there. So we just got to find the 90-degree angle, and it's pretty self-explanatory after that, just base times height. All right, 25, find the area of each composite figure. So this one's pretty much saying this height is 17, this is 8, and then the height, it looks to be 15. So what I could do is just chop this up into two different, I could have a rectangle, or a square, I mean, and then a triangle. So to find the area of just inside here, I would do 15 times 15, right? So 15 times 15 is 225. And then the triangle is going to be 17 times, oh, no, sorry, not 17. It's going to be, because the height of the triangle is 15. And remember, it's base times height divided by 2. So I'd have to do 8 times 15 over 2. So then 8 times 15 is 120 divided by 2 is going to be 60. So all in all, inside the square here is 225. Inside the triangle here is 60. So I'm going to add those two together, and that's going to be 345. But I think I might be a little bit off here. So 8 times 15. Oh, the one thing I forgot to do here. Let me fix this real quick. It looks like I added wrong. So 225 plus 60 is going to give you 285. And that's going to be centimeters squared. That's your final answer. All right, skip this page. 27. We're going to find the area of the polygon. So it looks like this is going to be a parallelogram. So again, the only thing, what I need to do is I have this, and I have this, and then I have a height, right? So this is a trapezoid, because there's two bases, right? So it's going to be 1/2. Well, actually, what I like to do is, instead of doing 1/2, I like to divide it by 2. So on the parentheses, I'll do the two bases, which would be 14 plus 6 And I'm going to multiply it by the height, which is 5.5, and then divide that by 2. 14 plus 6 is 20, and then 20 times 5.5 is 110. Divided by 2, it's going to be 55. And that is inches squared. All right, 29. If this is 8, that means this is 8. And then we need to add, this is 14, so that means we'll add this and 8. So, so this looks to be a kite, so we're going to do diagonal 1 times diagonal 2 over 2. Diagonal 1 could be just this 8 plus this 8, so it would be 16 times 14. For diagonal 2 would be 14 plus 18, so diagonal 2. If I were to say list everything, diagonal 1 is going to be 16, diagonal 2 is going to be 22. So multiply this by 22 and divide it by 2. 16 times 22 is 352. And then I'm going to divide it by 2, and I get 176. And that would be inches squared. All right, 31. We have to determine if it's scalene, isosceles, equilateral. Explain. So what I would need to do to just get the bare minimum of work is I got to find the lengths of all the sides. So this right here would make a triangle so that I would be able to find the length of that from B to C. So right here is 2, and then this is 1, 2, 3, 4. So for side BC, I would do 2 squared, which is 4, plus 4 squared, which is 16, is equal to C squared. And C is this line right here. So that would be 20 is equal to C squared. I would then take the square root of both of these to get just C. So then square root of 20 is equal to 4.5. All right, so I know now that B to C is 4.5, okay? Now what I'm gonna do next is, from A to B, I'm gonna draw that same right triangle. This is 2, and this is 1, 2, 3, 4. And I'm looking for C, which is this one, BA. So BA, and then BA is the same thing, actually. It's 2 squared, which is 4, plus 16, which is this 4 squared, is going to be equal to C squared. So, like, look at this, same thing right here. These are the same equations. So you're going to get C is equal to 4.5. So then I know that this side right here is going to be 4.5. And then finally this one right here from A to C. A to C is going to be 2 by 2. So automatically I know that, obviously 2 squared plus 2 squared is equal to C squared. So I'm trying to find this length right here. This equation does not match up to this one or this one. So what that tells me is that it has 2 sides that are equal, which would make it isosceles. Remember, you got to have this work in here to get full credit. All right, I'm going to erase some of this just so you guys can see what my work is. 33, we're going to do the same exact thing. There's a triangle here, and I need to prove the length of the sides and make a determination of if it's isosceles, equilateral, or scalene. So the first thing I'm going to do, let's do AB. AB would be right here, and this is 1, 2, 3. This is 1, 2, 3. So 3 squared plus 3 squared is equal to C squared. C being A to B. That'd be 9 plus 9 is equal to C squared. C squared is equal to 18. So I take the square root of 18, and I get 4.2. so this right here is 4.2. Now I gotta go, I can count B to C. It's gonna be 1, 2, 3, 4, 5, 6. So that's 6. And then I gotta do AC. So AC, gonna make that right triangle here. This is gonna be 1, 2, 3. This is gonna be 1, 2, 3. So that'd be 3 squared plus 3 squared is equal to C squared, C being AC. And look at this again, same equation. So that means at the very end, it's going to be C is equal to 4.2. So then, what that would mean is that AB is equal to 4.2, AC is equal to 4.2, two sides are the same, so it's going to be isosceles. All right, find the perimeter and area of the pentagon. So, what it looks like I can do here is that I can cut some stuff up. So, how about we cut B to E up so that I have a triangle. And then on the lower part here, I know that I have a height and I also have a base. So from B to E would be 1, 2, 3, 4, 5, 6, 7, 8. So this line right here is 8. And then if I were to make this right angle right here, from here to here, it's going to be 1, 2, 3, 4. That's your right angle right there. That's your height right there. So what I could do is, I would just need to, actually, I'm sorry, I kind of screwed this one up. Actually, I do need to know that height, but then I also need to know this base right here. 1, 2, 3, 4, 5. So this is 6. So as you can see, there are two diagonals, or two bases, I guess you could say. This one right here and this one right here. So those two bases, and then we have a height of 4. So base 1 is equal to 8, base 2 is equal to 6, and my height is going to be equal to 4. And I can just plug that in to the area of a trapezoid. So that's going to be 8 plus 6 times 4 over 2. So that would be 14 times 4 over 2. So that would be 14 times 4 is 56, divided by 2 is 28. So what that means is, this base is still 8, but this trapezoid right here is going to be, sorry, not 56, 28. Now we gotta do this triangle right here. So I know from the height is gonna be 2 right there, and the base is 8. So for the triangle, I'm gonna do base times height. So it's gonna be 8 times 2. I'm gonna divide that by 2. So it'll be 16 divided by 2, which is then 8. So now, this top triangle right here is going to be 8. So all I need to do is, I have the area of both of these figures, just add them together. So 28 plus 8 is going to be give me an area that is equal to 36 units squared. So now, after I've done that, got to find the perimeter, which is the outside. So we can start with the simple stuff, which is, this was 6, and then That looks to be the only one we know, but what we can do is we can do our right triangles. So this is 1, and then this is 1, 2, 3, 4. So let me just erase this real quick so you can see my work. So I'm moving on to perimeter now. Just keep track with me after I found my area. So this is 1, this is 4, and then I'm looking for B to C. So B to C, or segment BC, is going to be 4 squared plus 1 squared is equal to that side, C squared. So that's 16 plus 1, which is equal to 17. Not equal to 17, sorry. C squared. 17 is equal to C squared, so I take the square root of 17. And I get 4.1. So I can mark on here that this is 4.1. Now I know if I just look over here, do this right triangle, I do 1, 2, 3, this is sides 4 and this side's 1, so BC and ED are going to be the same. So again, BC and ED are going to be the same. These two are the same. This is 4.1. So now I need to find BA and AE, and I'm assuming they're going to be these two are going to be identical as well. So what do? Do the same thing. Just got to do it over again. So what I'm going to do is draw my right triangles here. This is 2. This is 1, 2, 3, 4. And that's going to give me this A to B. So A to B, or segment AB, is going to be 2 squared plus 4 squared is equal to that line, so C squared. So 4 plus 16 is going to be C squared. So 20 is equal to C squared. So I take the square root of 20, and I get 4.5. So that means this right here is going to be 4.5. And then finally, we're looking for AE, but if I do the same thing, if I draw this triangle to find the third side, I'm going to get the same. This is going to be 2, this is going to be 4, and it's going to look exactly like this one. So I can then assume that AB is going to be equal to AE. So that's going to be 4.5. So now, what I need to do is add all of these up. So it's going to be 4.5 plus 4.5 plus 4.1 plus 4.1 plus 6 is going to be 23.2. So my perimeter is equal to 23.2 units. Oh, not squared. It was 23.2 units. And that's all I have. So as always, if you have any questions, email me. My email is Eric.Van Ruden at Muskego, Norway.org. Okay. Other than that, we will have review tomorrow, or we'll have the review and then we'll have the test, and we'll go from there. So remember, this is a test. This is worth a lot of points. Email me if you have any questions. All right. Thank you.